Algebra word problems number 35C, write solve equations for mixtures. We're going to solve for x. Now some mixture problems you need to solve for x and y, and those are going to be my other mixture videos. This one is just solving for x. Making a table is the easiest way to find the equations needed to solve a mixture problem. Here's our problem. How many pounds of chocolates costing $2 per pound, that's the first box, should be mixed with 3 pounds of chocolates costing $1.60 per pound to obtain a mixture of chocolates costing $1.70 per pound. So it's saying we need to find how many pounds of $2 chocolate to mix with the $1.60 per pound chocolate to make a new box of $1.70 per pound chocolate. And because we know that this is 3 pounds, but we don't know what this is, we're going to let x stand for the number of pounds we need to add these together to get this one. All right? So remember, we're adding these two together, okay? Not multiplying, they're adding. All right, so here's our table. And right here is the $2 chocolate, okay? So these are all chocolate. This is all chocolate. That's why I didn't really label them. Because we're dealing with all chocolates, aren't we? The only way to tell them apart is the price, okay? So in our table, we've got the $2 chocolate, and we've got the $1.60 per pound chocolate, and we've got the $1.70 per pound chocolate. So here, $2, $1.60, and $1.70. $2, $1.60, and $1.70. So looking at this as row A, B, and C, our first row is going to be the cost per pound going across. The second row is going to be the number of pounds going across. So we know that this is X pounds, because we don't know what it is. This is 3 pounds, and this is whatever these two are equal together, right? So the first one's X, the second one's 3, and the third one is X plus 3. It's whatever these two are added together. So we've got a plus sign there. The last row is the value in the dollar amount. If I bought $2 per pound chocolate and I bought 3 pounds, then it would be $6, wouldn't it? So this is going to depend on what X is, and it's the value that you're going to pay for all the chocolate pounds you're buying. Same with this one. So we're going to multiply coming straight down in all 3 columns. We're going to multiply, multiply, multiply going straight down, all right? So now we have our equation, because we've got 2 times x is 2x, and we're going to add that to $1.60 times 3, which comes out to $4.80. We don't need the 0, that's extra. So I'm just going to put 4.8 to make my math easier. And we've got $1.70 times x plus 3. So I'm going to make it 1.7 x plus 3 to make my math easier. All right. You don't want to have to multiply another placeholder when it's just a 0. All right. So now our equation is 2x plus 4.8 equals 1.7 times x plus 3. That's our equation. And we need to remove the parentheses from the right side of the equal sign. And we're going to do that with the distributive property by multiplying by the 1.7 to each one. Okay? So if you remember the mother bird in the parentheses nest, she takes turns going to the first one and then the second one when she feeds them. Okay? So first one we've got is 1.7 times x. That's easy. It's 1.7x. 1.7 times 3, do a little math on the side, it comes out to 5.1. So remember, if there's one hop over in the decimal point in the equation, there's one hop over in the product. So that gives us 5.1. So now for the right side, we've got 1.7x plus 5.1, and we put that back into our equation. We have a new equation. 2x plus 4.8 equals 1.7x plus 5.1. Now we need to do number 2, the second step. Okay, so here's our equation. 2x plus 4.8 equals 1.7x plus 5.1. We can subtract 4.8 from both sides of the equal sign to begin to isolate x to one side. So I like to take the smaller one away from the bigger one. It's easier than going into the negatives, which you can do, but that's all right. So we're going to take 4.8 away from both sides of the equal sign. So 4.8, take away 4.8 creates a 0 pair. If you have 4.8 and you take 4.8 away, you've got none, right? So now that's gone. 5.1 minus 4.8 comes out to 0.3. So now our new equation is 2x equals 1.7x plus 0.3. Well, now we could subtract 1.7x from both sides to continue isolating x. I take 1.7 away from this side and 1.7 away from this side of the equal sign. This creates a 0 pair again, so we get rid of it. And 2, which is really 2.0, isn't it? Take away 1.7 comes out to 0.3x equals 0.3 from this side. Well, we still need to isolate x, so we can divide both sides by this 0.3 to isolate the x to one side on the left. So we do. We divide this side by 0.3 and this side by 0.3. 0.3 over 0.3 equals 1. Remember, when the numerator and denominator are the same, it equals 1. So now we know x equals 1. And that means we need 1 pound of $2 per pound chocolate to make our mixture. So now this isn't an x anymore, is it? We know that we need 1 pound of this to add to the 3 pounds of this. That'll give us 4 pounds of this, won't it? And it didn't ask for that, but now we know it, don't we? It asked for that. We went through all of this work just to find out that we need 1 pound of chocolate. Isn't that something? All right, coming up, we're going to be working with 2 variables, an x and a y, where now that you found x, you can plug it back into a second equation to solve for y, all right? So, remember, this is our table, cost per pound, the number of pounds, and then it helps you write the equation when you multiply coming straight down each column, all right? Remember how to take the parentheses away and do your inverse operations to isolate x, and you should be fine, okay? This is actually the first part of solving for x and y. You would do this to solve for x, and like I said, you would plug whatever you got for x in to the equation for x, and then you'd be able to solve for y. I'm going to do that coming up in video number 36A. Hope to see you there. Bye.